Our next speaker is Mr. Bob Knodel of Globebusters. Big round of applause for Bob.
All right. Wow, thank you. Wow, this is really an amazing turnout. Very impressive, very impressive. All right, cool. So in case any of you are wondering, yes, this is my motorcycle. I love it. It's my Harley V-Rod. And I've had it for, gosh, a long time, almost since it was brand new. I got it in 2004. And I ride it all over the place, really love it. So that's it, just thought I'd show it off to you. So, all right, guys, so if you don't know who I am, I do the Globebuster show with Jeranism, Wits It Gets It. There's actually several of us, John TheMorgile, Zack, Good Times for All has recently joined us. And yeah, we've been doing this for like 6 years now. And our approach is generally to try and simplify things and explain it without getting too much into the mathematics or the technical side of it, even though sometimes that can't be helped. But so we're going to talk about something today that is kind of near and dear to my heart, and it's kind of a personal thing because there's a lot of people that when you're a flat earther, for some reason flat earthers just want to automatically disavow the existence of gravity, okay? Very interesting because the way that the creator actually made this place that we're in, the very design of it as an electrical circuit exerts a downward pressure that we can call gravity. However, it is not something that occurs from mass attracting mass or anything like that. It is purely an electrostatic function, and we're tie that together with one of the prime components of it, known as the firmament. So I'll go ahead and start with that. Give me a second here. Let me get my notes up. Come on, mouse, work. There we go. Ew, I know, this guy. Whoops. That is not what we wanted to do. Go forward. We're off to a roaring start. Okay, so let's go back one. Okay. So as I said, we're going to talk about two major components of the flat Earth model today, and then I'm going to tie them together in a very interesting way that increases the preponderance of evidence in a very interesting way with regards to the flat Earth model. The two main things I'm going to talk about today, as I said, was the existence of the firmament on the flat Earth and how the existence of said structure fits in with our proposed gravitational model we call the downward electrostatic vector. Okay? That's kind of our new name for gravity, the downward electrostatic vector. Okay, and I have to start out by saying that it disturbs me greatly when I hear flat earthers outright proclaim there is no such thing as gravity. While I agree with that assertion on a few technical levels, the claim itself only serves to make us seem ignorant in the eyes of the globe believers who have been indoctrinated with the mindset that all it takes to prove gravity is to just drop a microphone and say, this is gravity. And of course, we're all familiar with Neil deGrasse Tyson and this particular clip.
If you spent any time on Twitter in the past 48 hours, then you heard about our next story. Rapper B.O.B. blowing up Twitter with his theories on the actual shape of the Earth.
Rapper B.O.B., perhaps you know him for hits like Airplanes and Nothing on You. He firmly believes that the Earth is flat.
So that's right, B.O.B. When you stand on the shoulders of those who came before, you might just see far enough to realize the Earth isn't flat. And by the way, this is called gravity. And
Yeesh. I know, it's bad, but what do we do about it? Okay. So the mainstream gives us a few definitions of gravity, which tells us that A, mass attracts mass, that B, gravity gives all physical objects weight, and C, it is the reason why things fall to the ground. Later definitions of gravity proposed by Albert Einstein tell us that gravity is caused by a bending of space-time. Utterly ridiculous, okay? So the Einstein explanation is, of course, without a doubt, the most ridiculous explanation, because A, space is a privation, meaning there's nothing in it. It's just space. It doesn't have a fabric. It doesn't have anything that it's made of. It's just space. Nikola Tesla knew this very, very well. And also, time is a man-made construct. It's a conceptual thing that, we can put it up against something and we can say, okay, the cesium decay rate of an atom, or a decay rate of a cesium atom takes this long, or 1 second, and we're going to call that 1 second, but that's still a conceptual matter on our part, how we're seeing it. So time, of course, like I said, it doesn't have any relation to reality in any tangible sense. Therefore, the idea that you can bend time in reality is a physical impossibility. This theory of bending time is also propped up by the famous thought experiment that if you take two men, give them each a clock, and then send one of them at near light speed across the galaxy, right, and then bring him back again, and you compare the clocks on the two men, you will see that the clock on the man, theoretically, that went all the way across the galaxy at light speed and came back, had slowed down, right? Well, it's a nice story, but there's obviously no evidence to prove that whatsoever. So, but they give that to us, and that allegedly proves that increasing velocities prove slowing time. It does nothing of the sort. There is, of course, no evidence to corroborate this whatsoever, but mainstream scientism is content to accept this explanation and story to prove reality as an axiomatic fact, okay? One thing that Einstein seems to have overlooked in his relative explanation is that from the man's point of view, it's rocketing across the galaxy, the man standing still is one who appears to be moving away from him at near light speed. And since everything is supposedly relative, how do we know which man is really traveling at near light velocity, right? It's all relative. It doesn't matter which one is going. So that was a major, major error that Einstein made in that little story, and mainstream, seems to kind of fail to address that. So furthermore, we are also shown a conceptual diagram. Let's get to that. And let's get to that. Boy, this thing has got a terrible mouse pad here. So we're shown a conceptual diagram of how the bending of fabric of space is causing distortion in space and causing objects to fall to the center of this newly created rectilinear coordinate system that our Earth occupies. And of course, as we're looking at this, we're seeing the fabric of space bend because Earth, of course, is exerting this mass, and it's causing the space to bend. But isn't it interesting that this space seems to go in a downward direction? What about up or left or right or all the other directions that it would seem to, bend space in? But no, they have to get it across to us that things are going to go down because it's bending space in a downward direction, which of course is utterly ridiculous. Again, there is zero proof, absolutely zero proof, that such a distortion in space even exists. Only in the equations of special relativity does this distortion exist and nowhere else. Relativity is nothing more than a nonsensical mathematical construct of which no part of it has ever been proved. Of course, anyone making this assertion is automatically considered a quack, because if you do not support relativity, you can kiss your hard-earned physics credentials goodbye, your job goodbye, your credibility goodbye. You will be kicked out of the mainstream scientific paradigm with no hope of ever returning it, and so many people have done that. Most scientists are too cowardly to challenge the Einstein rubbish, so they attempt to work within its framework. Unfortunately, Any true scientific discovery or innovation has been halted for the past century because Einstein utterly derailed scientific innovation with his ridiculous theories. Okay, so the next thing I'm going to bring up here, I'm going to let this play in the background. I'm not going to run the audio on it, so you don't need to run the audio. So you guys are probably familiar with this. So as far as Newton's theory of gravity being more centered around the mass attracting mass idea, it is cumbersome at best. Physicists try to demonstrate this phenomenon by replicating a portion of the Cavendish experiment. The original purpose of the Cavendish experiment was to determine the mass and specific gravity of the Earth. Allegedly, the Cavendish experiment is supposed to tell us that the actual strength of, the gravitational field, but I have yet to see any of that information gleaned out of any of these experiments. And in fact, it's all they can do to get these things to even show mass attracting to mass. And if you guys are familiar with one of the shows that we did on Globebusters, this particular video Slice Barkane did with his Cavendish experiment I debunked it, and it was very easy to do because basically what happened is he was having electrostatic forces that were actually causing these balls to move. He was using everything that was highly susceptible to electrostatic charge and highly influenceable by that. So, of course, when one tries to determine just exactly what mass is today, it becomes nearly impossible because all the different takes on what mass is. Now, mass, in its simplest form, is just weight with a SI unit of kilograms. It is measured on a balance. You know what a balance is. It's like a scale, and you have like a weight. You hang a calibrated weight on one side, and then you put the object on the other side. It's just a scale, essentially. But they have to get real technical and call it a balance, and that way, that's how you determine what mass is. So, in its simplest form, it's got the balance, and some say motion increases mass, okay? Well, that's one of those things about mass that is highly in debate. Einstein said that if mass was increased towards the speed of light, it would become infinite. Of course, again, we have absolutely no proof of that whatsoever. None of the colliders, particle colliders show that mass becomes infinite under these particles, nothing like that. Otherwise, there would be some really, really big explosions. So a lot of these equations that even show, gravity and mass, they can't even figure out what it's supposed to be, primarily because we don't really know what mass is. There's too many definitions, too many takes on it as to what it was. So, some people say that quarks represent 99% of the protons in mass. Others say 1% do. Another problem with this, again, you have major PhD physicists that are at complete opposite ends of the scale. One saying 99%, one saying 1%. How is anybody supposed to figure that out? How is anybody ever supposed to be able to understand what mass is, okay? So that's just some of the problems with that. And, it is very problematic to get these Cavendish experiments to actually work out. And as you can see, Sly's got his graphic here, and this is how it's supposed to work in a perfect world. But eventually what actually happens is it keeps coming and it will short out against the bowling ball or the steel mass, and then it will bounce back. And pretty soon the charge is completely gone, and then it will no longer attract anything to it. And that's something we debunked on this. So, to be fair, though, I will say that, the mass attracting mass prospect that was proposed by Isaac Newton does have some evidence that is logically extrapolated from a cousin of gravity known as magnetism. And I'll explain that to you in just a second. So right now I'm going to play a part of a video here, or video, that was actually done by Good Times for All, which is Zack Zabala. And what we want to show in this is basically how we can extrapolate a mass attracting mass type of environment, okay? Because we've also proposed before that, you know, gravity and electrostatic force and electromagnetic force are three heads of the same beast, okay? So I'm going to play this and we'll kind of get a better idea of how that works out, and then we'll move forward. So here we go, and this one will do audio.
Hello everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala here if you prefer. In this video, we will be taking a look at the difference between coherent versus incoherent magnetism. We will again start with some quotes from Ken Wheeler.
Everything is electrical. The only thing that actually defines a magnet is field coherency. Before this thing is magnetic attraction, that which we call magnetic attraction, is it something autonomous from gravity? No, it's not. The only thing that defines or differentiates out the two is field coherency. Something separate and autonomous. Well, here's gravity here, and here's electricity here, and here's magnetism. No, all that shit is the same crap. Like ice, water, and steam. They're not different things. Right now, by any definition of the term, and the force required to move this object, 50 pounds. Wow, that's over a piece of metal. You know, it still weighs 4 ounces if you put it over the dirt or, you know, wood. Yeah, do you know why? Because then we only have one object that has field coherence. I'm not able to induce induction. I'm not able to induce field coherence in a piece of wood or the dirt.
As you heard Ken Wheeler state, everything is electrical. Not only is it all electrical, but he adamantly shouts that magnetism, gravity, and electricity are all the same thing. The part we will focus this video on is the quote where he states the only difference between magnetism and gravity is field coherency. Instead of trying to tell you what he means, I will show you with a few demonstrations. First, we will take a look at two coherent objects and how they interact with each other. Here we have two cylinder magnets with the north poles of the magnets painted red. As you can see, when I try to place the red ends near each other, the other magnet tries to flip around to align with the non-painted end. This is because both objects are coherent, so the attraction and repulsion are both present. It pushes away when the poles are the same, and attracts when reversed. Now we will take a look at how multiple magnets, when not aligned, become incoherent. First, we will observe the magnetic field when the magnets are all lined up and coherent. As you can see, the more magnets we align pole to pole, the stronger the magnetic field gets. However, this is the complete opposite when the poles are not aligned. As you can see, the more magnets we add to our incoherent mass, the weaker the magnetic field gets. Now let's take a look at how a coherent object, the cylinder magnet, interacts with the large incoherent mass of magnets and ball bearings. As you can see, the red pole of the magnet is attracted to the mass, so we might assume that the bare pole of the magnet would repel. Yet this is not the case. As I flip the magnet over, the bare end is also attracted to the mass. So how does this relate to what we are calling gravity? Like gravity, incoherent magnetism is an attractive-only force. No matter which pole of the magnet is placed near it, the incoherent magnetic field is always attracted and never repelled.
One thing that is really important to note about this is that that clump of magnets which all have their own positive and negative poles on them. Once they're put together like that, they become incoherent, and it doesn't matter where you stick a coherent magnetic source on it, it will attract it, okay? And now that is absolutely never true of coherent magnets. Anytime you have a north-south, they will attract, or if you go north-north, they will always repel. But when you make it incoherent, then it is always attractive. Now this is something that they say about gravity, right? Now I'm going to tell you, even though we call gravity something, it really is not a thing. Gravity is actually electrical, but the powers that be, in order to kind of hide the idea that, what's sticking us to the ground and what's causing things going down is gravity, is this electrical thing. And the reason they do that is because then they can't tie in the planets orbiting or us orbiting the sun, or it doesn't support the heliocentric model. This is the whole reason why they make up this entire gravity myth, okay? But to say that there isn't some sort of electrical static field that is literally holding us down on the ground, that's crazy, because it is there, and you cannot have a relative density disequilibrium type of model without a bias that is holding down anything, everything. And electrostatic forces act on all matter. They act on all matter, and this includes gas. So let's continue on here.
All matter is made up of charged particles, and like magnets, these particles have poles. The Earth and everything on it is ultimately a huge mass of charged particles. This is why everything is attracted towards the Earth. There are a few apparent exceptions to this rule, like helium balloons and rain clouds, and we will cover this in another video. In closing, the Earth attracts everything to it by virtue of its incoherent electromagnetic field, and this is why we find a very weak bias between up and down, and ultimately what we call gravity.
Nice. And thank you to Zack, Good Times for All, for that video. He's been kind of staying with us for the last year as a roommate, and it's kind of nice to have him because he makes videos, he and I collaborate on them, and then he actually puts them together. So it makes it kind of nice for me to be able to have him to do that. So let's see. So contrary to the incoherent field growing weaker with magnetic mass being added to it, science tells us that the more mass something contains, the stronger the gravitational field becomes. Well, unlike what we just saw there, that is in complete opposition to what we just witnessed. The more incoherent the magnetic field becomes, the weaker it becomes. So although we do have supporting evidence in the magnetic model for so-called gravity as far as mass attracting mass, because all mass is made up of electrostatic particles, we do not have any corroborating evidence that says that when mass gets bigger, that it will cause a greater gravitational pull. And in fact, all the experimental data says no, that's not true at all. And again, there is no explanation in mainstream science or demonstration that proves this to be true. So there you have that on that. So basically, we may call it gravity, but gravity, really just means weight, okay? That's what gravitas means, or gravity, and it has been perverted by the mainstream to mean something akin of mass attracting mass, and that simply does not happen. And if it does, it certainly doesn't do it the way that they claim that it does. The more likely and the more demonstrable and explainable position of why things might attract to each other and why we attract to the ground is this electrostatic force that is incoherent. So right now I'd like to switch gears and talk about something called the firmament, okay? And we're going to tie this all together here. So as I've claimed on years now, the evidence for such a structure is voluminous, okay? I'm going to quickly run down a list of items that, when taken collectively as a preponderance of evidence for the firmament, it makes its reality an almost impossible, it's impossible to deny it. I mean, there's so much evidence that shows that this firmament is actually there in so many ways. You know, and I didn't even go into the optical characteristics. That is one of the things that is documented in some of the documents that I have that the mainstream, the CIA has covered. But there's so many other things that we are just simply led down another path to believe something else about these direct evidences for the firmament. So we're going to go over those. So the firmament is described in Job 37:18. It says, "Hast thou with him spread out the sky, which is strong, and as a molten looking glass." Okay? Well, to me, this sounds very much like a crystalline structure, okay? And it is further described to contain a vaulted area, right, where the sun, the moon, and the stars reside. And I find that very interesting because even in the mainstream model, if you take the mainstream model of, you know, where I believe the lower limit of the firmament is, which would be 50 to 60 miles, 62 miles, or 90 to 100 kilometers, directly above that, there is a vault, which is called the thermosphere. And what's interesting about the thermosphere is it gets up to temperatures about 4,500 degrees Fahrenheit. Now, isn't that interesting that the mainstream would actually, you know, cop to that, when in the flat Earth model, that's exactly where the sun would be. So I think that's kind of an interesting, you know, thing, just as an FYI. So one other thing that tells us that there is something up there is the presence of sprites and videos, okay? So, or sprites and videos, sprites and elves, excuse me. Sprites and elves are essentially lightning striking in an upward direction. The interesting thing about them is the strike seems to flatten out right at about the 100 kilometers or the 62-mile mark, right? And if you understand how circuits work, in order to get a current flow or an electrical strike, either up or down, there has to be a fairly substantial difference of electrical potential, right? So when we're looking at an electrical storm and we see lightning strike to the ground, actually it strikes up to this cloud first and then strikes to the ground, we see that as nature equalizing itself. But what a lot of people are not aware of is that there is lightning that strikes upwards. And the interesting thing about the sprites and elves that strike upwards is when they go up and they seem to hit something right at the 90 to 100 kilometer boundary. And when it does, it flattens out. Just like it hit a brick wall, just like it hit some sort of a crystal wall in space. You know, it's really super interesting. So let's take a look at this video and we'll actually look at some of these sprites and elves and find out what the mainstream actually claims they are. Here we go.
Did you know that storm clouds have a whole other world of flashing lights just above them? Above the storms, red jellyfish-shaped lights, blue streaks, and huge donut-shaped halos flash.
They're called transient luminous events, or TLEs.
The TLEs we see most often are called sprites, elves, and blue jets. But before we get any further with those, let's take a look at what lightning is. Lightning is caused by electrical charges in clouds. These electrical charges are created when ice, snow, and water droplets in thunderstorms collide at high speed. All of those collisions build up static electricity in the cloud, and the charges can be huge. If they separate, the lower part of the cloud becomes negatively charged, while the upper part of the cloud can be positively charged. The positive and negative charges cancel each other out by shooting electricity between them, and that electricity is lightning. When a lightning bolt strikes the ground, it can leave the top of the thunderstorm with some negative charge. This creates bursts of electromagnetic activity in the upper atmosphere, and it's believed that those bursts are TLEs, the sprites, the elves, and the blue jets.
SPRITE stands for stratospheric mesospheric perturbations resulting from intense thunderstorm electrification.
Sprites start as a huge ball of red light with tendrils that stream down and turn purple, then blue.
ELV stands for emissions of light and very low frequency perturbations due to electromagnetic pulse sources.
ELVs start out as a flash of light that ripples out into a flat disk of glowing red-purple light, kind of like a halo or a huge donut in the sky. Blue jets are blue, and blue jet stands for Blue Jets, no acronym here. They shoot up from the top of storm clouds in the shape of narrow blue cones, and they are fast. They reach speeds of hundreds of kilometers per second, and as they shoot up, they fan out and disappear. So the next time you're watching some crazy lightning, just imagine the colorful light show that could be happening just above those clouds.
All right, so aren't those cool? I had never seen sprites or elves or ever even heard of them before. You know, I started looking into firmament studies, and you know, when you do that, you start finding all these things that corroborate that there must be something up there that's physical. And as I said, you know, by profession, I don't know, one thing that I have done professionally my whole life is I am an electrical engineer. I specialize in RF, radio, microwave, satellite communications, and you can imagine that must have been a very hard thing for me to get through to figure out how satellite communications can be faked. Well, actually, it's quite easy, quite easy. So, you know, having the electrical engineering training, these type of circuits are very, very basic. You cannot have any type of current flow without a massive difference of potential that is causing these electrostatic current flows, okay? So, one of the next things that tells us that there is a firmament up there, something else that's up there, is something that again, I didn't know about this until we started looking into the phenomenon of the firmament, and that is something that's called a laser guide star. Well, what is a laser guide star? Basically, what they do, and this is really crazy, is they will, when you look up at a star, right, and you see them twinkling, right, that twinkling is caused from atmospheric distortion. So you get the atmosphere, you know, rising heat, you know, particulates, whatever, will cause the actual star, as you're looking at it through a telescope, to twinkle, and it will distort, you know. So what the adaptive optics or the laser guide star does is it fires a yellow laser beam, you know, a specific nanometer wavelength, up at what they call the sodium layer. Does anybody want to take a guess where that sodium layer is? That sodium layer? I'll tell you this, it's where it should never be. It's at between 90 and 100 kilometers, or around 60, 62 miles. Wow, what a coincidence, right? So many things happen at that 62-mile mark, it is impossible to ignore. So what do they do with this laser guide star? So they fire a laser up there, and the sodium layer, of course sodium is like salt or a crystalline type of formation, and again, mind you, another crystalline would be described as the firmament, a crystalline type of form. And what it supposedly does is, well, it's not what it supposedly does, it actually does do this, is it causes a star to emerge, a low magnitude, which means high brightness star, or something emulating a star, to actually emerge. Then, by that calibrated light, if they shine it next to a a high magnitude star, which is a very low density star, they can remove the density, not the density, but the distortion in the atmosphere that's caused from the atmospheric density, and they can get a much, much, much clearer picture of that high magnitude star or low density star. So, I'm going to go ahead and let this guy, Professor Simon, kind of tell you what this is. Now, who this Professor Simon guy is he's kind of like one of those wacky front men like Einstein, but he is the scientific lead on the SOFIA project. And if you don't know what SOFIA is basically a telescope that rides around in the back of a 747, okay? And so they're looking out of the 747 and they're looking up at the stars. And ironically, the SOFIA is said to have even better resolution than Hubble, which is kind of bizarre because Hubble, theoretically, is supposed to be out in space, and it does not have near the resolution that SOFIA does. But so let's look at adaptive optics, brought to you by Professor Simon, and he'll explain to you kind of how it works, maybe better than I did. Here we go. Oops. I hope I started at the beginning.
If you see a large telescope at night, you'll often see orange laser beams pointing out of the dome. Astronomers have turned to a method called adaptive optics. Sophisticated, deformable mirrors controlled by computers that can correct in real time the distortion caused by the turbulence or twinkling of the Earth's atmosphere. Adaptive optics require a fairly bright reference star that is very close to the object under study. High up in the atmosphere is a layer that can be excited to glow by the single wavelength light of an orange sodium laser. This artificial star, made by the laser, twinkles in the distortion of the Earth's atmosphere. These distortions are measured in real time and a negative pattern of movement produced. This inverted twinkle can be used to distort a thin metal mirror. At the back of the mirror are electric magnets, a bit like a sound coil inside a loudspeaker. Hundreds of these bend tiny parts of the mirror, distorting its shape and cancelling out the twinkle. Light from a star near the laser can now be seen in much greater clarity. The latest adaptive optical telescopes are 10 times sharper than the Hubble Space Telescope.
Whoops. What did he just say? They're 10 times sharper than the Hubble Space Telescope? Now, again, the whole purpose of this system is to remove atmospheric distortion. And although it's good, it's not that good, okay? So how in the world could it possibly be better than the Hubble Space Telescope when the Hubble Space Telescope is supposedly 350, 400 kilometers up? Oops. Let's continue.
This is both because on the ground they can have a larger mirror, so gather more light, and they can now eliminate most of the twinkle in the Earth's atmosphere using adaptive optics. The world's largest telescope, the TMT, or 30-meter telescope, is about to be built on top of a mountain in Hawaii called Mauna Kea. The TMT will have 492 segmented mirrors. This will make it 9 times the power of the Keck, which is currently the world's largest telescope. And we'll use the latest generation of the Laser Guide Star adaptive optics system. Keep your eyes on the skies. The truth is out there.
You ain't telling. is not telling the truth. I can tell you that much for sure. Okay? So isn't it interesting that we're putting all these resources on these, adaptive optics, which admittedly is great technology. It's pretty cool. But if we have space-based telescopes, why do we even need it? And what's really interesting, and I don't know if many of you have ever heard the conversation between a guy named Robert Bassano, Project Veritas, and a NASA administrator for the Hubble telescope. But one thing I found very interesting is it was revealed in that conversation that even after 30 years of being the director of this project for NASA, of the Hubble Space Telescope, this guy has never once seen a live feed off of the Hubble telescope. I was like, what's up with that? Then who gets to see it? The universities? Well, they're not claiming. It turns out that who gets to see it are the intelligence agencies. Gee, I wonder why they need that, okay? So it's just amazing how they circumvent, and even NASA's own people are not able to see their so-called technology that's up there in space. So, crazy. Anyway, that's just an aside note. Moving on to our next little item that I believe proves that there is a firmament. Now, granted, this article came out several years ago, actually in 2014, so 7 years ago, and it claims that this Star Trek invisible shield is up 7,200 miles. Now, I will tell you that the way that astronomers gauge distances is way off, and probably it's more likely that this was an insert by an intelligence agency that said 7,200 miles, because why would there be something in space that would be a Star Trek-like shield, right, at 7,200 miles up? It's supposed to be a vacuum up there, right? Why would there be something up there that stops all incoming X-ray radiation, gamma radiation, etc.? So some of the interesting comments that are listed in this is they say, at 7,200 miles up, scientists discovered a shield that was blocking the killer electrons emanating from the Van Allen radiation belt. They described it by saying, it's almost like these electrons are running into a glass wall in space. Wow. Tell it like it is, right? Okay, said Baker, the study's lead author, somewhat like the shields created by the force fields on Star Trek that were used to repel alien weapons. We are seeing an invisible shield blocking these electrons. It's an extremely puzzling phenomenon. Yeah, I bet it is, especially when you're in a region of space that is intentionally, for all purposes, void of any matter whatsoever. I mean, even in the thermosphere, which is only, getting up into, above 100 kilometers type of stuff, they say that the reason that you can't really measure that 4,500 degree temperature that's, above that bottom layer of the firmament is because even the air molecules are too sparse. So if matter is so sparse, then how are we going up another, 46 or 4,500 miles, and all of a sudden we have a Star Trek shield there? It doesn't make a lot of sense. They just tell us that they're there, and they expect us to believe it with no logical reasoning, measurement, or anything like that. They just tell it's there, and all the fanboys are like, yeah, take that, flat earthers. All right, so next thing that we have, oopsie, come on, there we go. Okay, I just wanted to show you this too. And again, remember, the thermosphere, this particular one only shows that it's going up to 1,500 degrees up into the thermosphere, right? But if you actually go over here, you see that it says the highly attenuated gas in this layer can reach 2,500 Celsius or 4,500 degrees, 4,530 Fahrenheit during the day. That is outrageous. What could possibly be causing those temperatures unless right here in this thermosphere area, which would be the cavernous area in the firmament, which is said to contain the sun. Makes sense to me. I don't know about you, but it makes a lot of sense to me. So the next thing that we have as far as evidence for a firmament is this. Yeah, well, that's actually a good one. That's a good optical piece of evidence. And I said that's some of the things I didn't cover was the optical evidences. And you also get, like coffee cup caustics, which I don't know if you guys know what they are, but if you shine a light on a certain point and you have a glass reflective surface around the outside, it will carry the outside light around to the other side of the coffee cup. Okay, and this is exactly what we're saying is happening with Antarctica, because they say, well, there's 24-hour daylight in Antarctica, which I believe there is, but what there is not in Antarctica is 24-hour sunlight. It's actually coming down to the south, and then it's going back up to the north, but lots of people have said, yes, there is a 24-hour daylight. Well, how that's happening is when the sun is actually on the opposite side, on the northern side, the light from the crystalline firmament is carrying it around in a coffee cup caustic type of effect, and it's lighting the skies in Antarctica. Okay, so that's a good point. So no, but what I was going to talk about was well, let me just ask you this, guys. What is the necessary antecedent for pressure? That's right, a container, okay? So we have down here on Earth a 14.7 psi pressure at sea level, okay? And it goes up a little bit, in gradients. By the time you get up to Mount Everest, it's like 6 or 7 psi, and, higher and higher and higher. And by the time you get up to 50, 100,000 feet, even here, it's almost completely gone. But the fact is that we do have a pressure, right? And they tell us that this pressure is right next to an adjacent vacuum of 10 to the negative 17th torr, which is a massive vacuum. I mean, massive. We cannot even produce a vacuum of that level here on Earth. The Sandusky facility, NASA Sandusky vacuum facility, will only go 4 times 10 to the negative 6th torr, which is nowhere near the outer space volume, right, vacuum, and it has to have concrete walls that are 8 foot thick of steel and concrete, okay? So you got to have a lot of, container there to be able to do that, right? And they try and tell us that gravity is the very, very weak force of gravity is actually holding our atmosphere down. Well, first of all, the force of gravity, when you calculate it out in newtons, when compared to the force that would be exerted on something trying to get out with a 14.7 psi, exceeds it by several orders of magnitude. There is no way possible that gravity could possibly hold in our atmosphere, okay? So what does that tell us? Well, that tells us that we have to be contained. That means that, well, we know we have the Earth on the ground. What do we have in the sky? Well, we got to have a firmament, and that firmament must drop down on all sides around the flat Earth. Otherwise, you don't have a container, do we? Right? So, let me see. Let me go ahead and read this. I kind of got away from where I was. Even though we do not see walls around the Earth and a covering above us, logic dictates that these constructs must be there to complete the container structure we inhabit. Mainstream scientism would have us believe that the incredibly weak force of gravity is capable of trapping the 14.7 psi atmosphere within an allegedly 10 to the negative 17 torr vacuum. Earth may suck, but not that much. Okay? All right, so the next thing we have, this one's kind of cool. Bring up my Adobe. Is over the years, I have collected several documents that have been released by the Central Intelligence Agency, the Army, the Air Force, NASA, and just several documents. Of course, you try and find these now, and they're virtually all gone. I have made these available on Globebuster shows, and if you guys really want copies of these, I can make all of these available to you. But the CIA themselves are some of the biggest people that are absolutely studying the firmament. And it's interesting because they show in some of these documents, first thing they say is, well, we're looking at a missile position in space computed relative to a flat, non-rotating Earth. And we see that flat, non-rotating Earth everywhere in all these documents. Everything. Why would everything be computed against a flat, non-rotating Earth? Unless, of course, it's a flat, non-rotating Earth, right? Makes a lot more sense than, whizzing around at 8 different directions, ultimately culminating at 1.3 million miles per hour through the universe. And yet, the stars remain the same year after year after year after year. Not buying it, NASA. Okay, so other things that they say in here. And this is, mind you, this particular document was declassified in 1949. And in 1949, even the CIA has admitted, without knowledge of the shape of the Earth and density of attracting masses, if it is a question of internal points. Okay, so they're saying there that they don't even know what the shape of the Earth is. Here they say it again. But since the shape of the Earth is not known, the true coordinates of the points B, L, and H are unknown to us, okay? And basically what these are talking about is these are coordinate points for the firmament over the top of us. And what they've done is they have used a very interesting instrument that is like a photometer. And what they're doing is they're actually studying the light that's coming off the firmament, right? So they're looking at it, they're documenting it. Back in 49, they still didn't know the shape of the Earth. They had at that point that they figured it was kind of like an ellipsoid. And even the ellipsoid looks very, very much more like the flat Earth model than the pair that Neil deGrasse Tyson tells us that we have today, right? So again, we're looking at the visual photometer of the daytime sky intended for measuring the brightness of the firmament, measuring the brightness along the almucanter of the sun and 5 to 6 points of the firmament located at various zenith distances. Again, on a flat Earth, firmament, all over the place. I mean, document after document after document. And some of these guys are hundreds of pages long. It's an interesting read, I'll tell you that much. I won't bore you with them now, but if you want them, I will make them available to you. And like I said, as soon as we put these out on Globebusters like 4 years ago, within a week, the CIA cleaned them up. They were gone. See ya. Crazy. All right. So that's the next thing. Let's move on. The next thing is the ionosphere. Okay, so the ionosphere was invented, and I do mean invented, because they basically had to invent it to explain some problems they were having with Marconi and his transatlantic radio shot. So the ionosphere was invented around 1901 to explain the impossible distances Marconi achieved with his 500 kilohertz spark gap transmitter. Science claims that this is a layer of the atmosphere that is highly charged and thus reflects radio signals down to Earth. Of course, a charged Gaussian surface, aka the firmament, would do the very same thing. Okay, so one of the things, being a nerd that I am, an electrical engineer, I'm also a ham radio operator. Been a ham radio operator for almost 50 years now. My call sign is KN0DEL. It's an amateur extra class call sign. And so I have worked a lot of DX, a lot of countries all around the world. Well, one of the things that they teach you when you're working this DX is they tell you that basically about every 11 years there's a sunspot cycle that dramatically increases the charge of the ionosphere, which then gives you better DX communications. And the way that it does that is it charges this ionospheric layer, right? And supposedly when you send a signal off of your Yagi, it goes up, it bounces off the ionosphere, comes down, bounces off the Earth, goes back up, bounces off the ionosphere, comes down, bounces off the Earth, all the way around the Earth, supposedly, right? Well, upon further reflection, when you think about the nature of electromagnetic and electrostatic waves, it is their very nature to return to earth ground. So the first time that they would have ever been directed towards earth ground, that would have been it. So, but of course, I was not looking for that then. Obviously, I am looking for it now, and I know that it's BS. It's not true at all. Okay, so basically, when he got these several thousand-mile distances, Marconi, on his radio, Spark radio, they knew that according to the heliocentric model, this was impossible, right? Because the curvature of the Earth would block it, right? Well, like many other things, the curvature of the Earth doesn't seem to block anything, and that is because there is no curvature of the Earth. And any of you that have known this, have been in flat Earth for a while, know full well that, we've never been able to find it. I am a board director of FE Core. We have done several laser experiments, several motion experiments. I mean, and there is no motion to this Earth. We've done interferometer experiments, of course. One thing that I have the distinct and dubious honor of is being a star of the movie called Behind the Curve. And with a little bit of creative editing in that movie, I was made to look like I was the only person in the history of mankind to prove the rotation of the Earth, right? Because we were working with a laser interferometer. We did detect a 15-degree-per-hour rotation, but it was not the Earth. We were then able to devise an experiment later on that allowed us to go on the same latitude lines, same latitude points, and vary our elevation in Pikes Peak, Colorado, and then out on the plains in Colorado, have a variance of about 10,000 feet, and we got a very dramatic difference in that rotation rate. Now, if it was the Earth that was rotating, there's no way that could possibly happen. But if it's the ether that is rotating, which it absolutely was, then that is exactly what we would expect is a toroidal behavior of the luminiferous ether. But I'm not going to go into that because that's kind of beyond the purview. But I do have that distinction if you've ever seen that movie. So, all right. So, and I already covered the thermosphere. And like I said, that's the thing that is pretty much telling us that there's something really hot up there, right in that zone where the flat Earth sun should be. And if we actually triangulate the sun and the moon, using a single source triangulation, the moon triangulates at about 3,400 miles up, and the sun triangulates at about, get this, 3,959 miles up, right? Supposedly the exact radius of the Earth. Interesting. Don't know if it's true, but it does triangulate out at that, which is very, very interesting. So let's put the pieces together here. It becomes pretty apparent that the preponderance of evidence given today tells us that not only is there a firmament, but our entire Earth realm appears to be enclosed in a self-sustaining biosphere. There is one final piece to this puzzle I need to explain, and we can put it all together. In a word, it would be capacitor, okay? And what a capacitor is essentially a Gaussian surface, okay? So a capacitor is a common electronic component found in virtually every electric circuit. In its simplest form, it is two Gaussian surfaces separated by an insulator of some sort, and finally, a charge is applied to the two surfaces. When this happens, the positive and negative charges on each Gaussian surface builds up and are held in place by a mutually attractive electrostatic charge. Between the Gaussian surfaces, there would be a linear gradient of electrostatic voltage potential at equidistant points. Well, what does that mean? Well, we know, and this is mainstream science that absolutely acknowledges this, that there is absolutely, all over the world, an electrostatic potential that does exist, and it is measured at the rate of 100 volts per meter, okay? So in other words, if you go 10 meters up, you're going to get, with a voltmeter, you're going to get a measurement of 1,000 volts between a point up 10 meters and the ground, okay? And if any of you have ever done tower work or anything like that and have come across ground while you're up on a tower and it knocks the crap out of you, well, you know what I'm talking about, okay? So this electrostatic charge is there, and it's been measured theoretically all the way up to 50 kilometers, okay? So, or that's like basically 31 miles. Now, if it goes all the way up to the lower level of the firmament, then it will have an electrostatic potential of 10 million volts. And that pretty much is the breadth of the electrostatic charge that goes on around the entire world, okay? So, let's see. So, if you kind of visualize, you have a metal plate here and a metal plate here, and you have just air as acting as the dielectric, and you have a 10 million volt difference of potential, you're going to have a perfectly aligned gradient of electrical charge at equidistant points along that, okay? Now, ironically, that is exactly what we have on Earth. Now, when you look at that paradigm under a ball Earth, it does not make any sense whatsoever. There is no explanation for it. In fact, they try and tell us the explanation for it is it has to do with incoming X-rays and gamma rays constantly charging with the electromagnetic field. But the problem is this voltage rate stays constant all the time, 24/7. There is an interesting heartbeat that goes on with it. It happens every day at like 1 p.m. or something like that, where there's a slight dip in it, and then it just keeps on continuing. So it's pretty interesting that that's actually happening. And so one thing that would happen also in that electrostatic plates, between the electrostatic plates, okay. Oh yeah, we're getting there, okay. Is that if you were to put something on the bottom and actually charge it, or charge it with the electric, with the negative potential on the top, it will draw pieces of paper, pieces of matter up to the top of it, right? In other words, there's that electrostatic force acting as gravity. And Zack actually has a video of that. We're going to watch that, and that will pretty much sum it up. And we'll see how that works, and here we go.
To start out, we will take a look at Earth's electrostatic field. This is important because we, along with all the matter in this known realm, are inside of an electrostatic field. The Earth itself has a measurable negative charge compared to the air above it all across the plane. As soon as you leave the surface, there is a positive charge in the air around you that grows in electrostatic potential the further you go up towards the sky. It is a steady, gradual rise in potential, which tells us, according to the laws of electricity, that we are between two Gaussian surfaces. A Gaussian surface is simply a surface that encloses or distributes a charge. If there were only one surface, the rate at which the positive potential grew would be different. Knowing that we are between two Gaussian surfaces, we can also know that certain phenomena will take place in all matter within the electric field, or area between the two surfaces. For this topic, we will first look at polarization through electrostatic induction. Electrostatic induction is a phenomenon where the positive and negative static charges on matter are slightly separated or polarized due to the electrostatic charge of its surrounding area. If one side of the object's surroundings is positive and the other negative, the negative charge on the object will be attracted to the positive area around it, while the positive charge on the object will be attracted to the negative area on the opposite side. So here on Earth, the positive charge on our bodies is always attracted down towards the Earth, and the negative will be attracted to the air above. This phenomena creates a slight force in that downward vector, because as soon as we leave the ground, we start becoming positively charged by the air around us and are now forced towards the negative of the ground. This is electrostatic acceleration. One might think that the attraction from above and below would cancel out completely, but it is the electrostatic gradient that creates a flow from the positive above to the negative below. Think of the Earth as a flat strainer, and there is a constant flow of water from above, moving very slowly, always applying a force in a downward direction. This would be considered a vector. The electrostatic potential difference getting stronger as you rise from the Earth will keep a steady pressure from above at all times until it reaches the Gaussian surface above. When we reverse the polarity of the electric field and put a negative surface above a positive one, we can reverse this electrostatic phenomenon and get things to stick to the upper plate as if it were the ground. This works with all types of matter.
Now, one thing I have to say, guys, is that one of the big objections we've had to this is people will say, oh, we can disprove that by simply putting a Faraday cage in line with this. And it's like, it's almost a laughable mistake because Faraday cages attenuate electromagnetic radiation, not electrostatic. There is nothing that is not susceptible to electrostatic charge, okay? So essentially what we can do is we can override that gravitational field. You may have heard of the Hutchinson effect or the Searle effect, something like that, where basically we change the electrostatic charge potential and we can create so-called anti-gravity. Okay, but the fact is that it's there, and this, nature, the creator has, by the very design of the firmament, and one of the characteristics of the firmament, gives us this downward electrostatic flow. And like I said, I think we've produced plenty of evidence that that firmament is there, and we know unequivocally it is statically charged. Let's continue.
You can move wood, iron filings, and even human hair with these forces. Believe it or not, you can even get water to bend. If the vector lines created between the two Gaussian surfaces are curved, all the matter will follow these field lines as well. In this demonstration, instead of using a flat plane, I use two circular objects as my Gaussian surfaces. You can see that as the water settles after being sloshed around by me turning the wheel on the Van de Graaff generator, it comes to rest with a curve in the surface following the electric field lines between the two spheres. This is why the ionosphere, a phenomenon that has never been created in a lab, is a theory yet to be verified, but is needed to create this phenomenon here on Earth. Maxwell himself changed Ampere's law, which stated plainly that without matter, no electrostatic field can exist. Maxwell changed it with no scientific evidence, allowing it to gather magically above our heads in free space. Density and electric potential go hand in hand. The denser something is, the more electric potential it can hold. Not that I believe in the model of the atom, but even the periodic table has a distinction on the amount of electric potential there is in the different elements. In this demonstration, I have a metal button hanging from helium balloons that keep the button buoyant just above the ground. By only adding more electrostatic potential to the button, you can see it will appear heavier and force the buoyant object down along the vector lines created by the electrostatic potential difference. Without changing the density of the medium or the object, one can change the overall weight, or gravitas, of the object. To do an actual experiment on the topic of gravitation, this variable of electrostatic acceleration must be taken into account at all times. Now we will take a look at how different electric potentials of gases act in this electrostatic medium we live in. Gases have different electric potentials, just like all matter does. The gas molecules that can hold more potential than those gas molecules around them are theoretically more dense and will have a stronger attraction towards the negative ground below. When these gases are carried along the downward vector by these electrostatic forces, the lighter gas gets displaced and becomes buoyant until it finds a place with the same electrostatic potential. This is why we have a pressure density gradient and are told the noble gases work their way up into the higher elevations and collect in layers above. This has not been verified by anyone I know, so at this point I cannot say if this is true or not. Through this induction, some pretty amazing things happen when large electric potential differences are applied to gases. When gases are placed into an area with a strong electric potential difference, we get the phenomenon known as ionic wind. If a person were to charge themselves up with 1 million volts of static electricity, they could blow out a candle almost 2 feet away from the gases rushing away from their fingertip because of the exceptional potential difference. We do know that when a gas loses its electric potential, it slows down so much that it turns into a liquid, like the condensation that forms on a window when it's cold outside.
the gases hit the cold window and transfer their potential energy to it, trying to mediate the temperature. In doing so, the gases lose their electric potential and turn into a liquid. Down here near the surface, the system is very dynamic, with all the plants and animals breathing, low altitude weather patterns constantly cycling, and Earth releasing gases from the deep at all times. We will never see all the gases lose their potential and turn into a liquid anytime soon, I hope.
Yeah, I hope not either. All right, guys, so basically that's, whoa, I'm stuck here. Get this away from here. Okay, so I'm just gonna say in closing, because I'm running out of time here, what I hope to have conveyed to you today is that the Creator has given us solid evidence of a firmament above and around us. When we logically deduce its electrical function and compare it to what our science knows about electrical circuits, it tells us with virtually zero doubt whatsoever that there is a constant downward pressure being exerted on all matter that keeps that ever so slight bias and gives us our absolute directions of up and down. And that's it. So there's our firmament. Thank you.
Thank you, Bob Knodel. Big round of applause for Bob Knodel, y'all.